Hi, this is King of Review. In this problem, we're asked to find the value of a. A is this entry here, when we have a to the power of 8 equals this matrix. And we're also given what a is equal to. So what we want to do here is let's look at a couple values of the exponent on a and see what value we get in this lower left-hand position. So let's look at a to the power of 1. Well, that's this matrix here, and it has a 2 in the lower left-hand position. Now let's look at a squared. A squared is the same thing as a times a, so we have matrix A times itself. So let's multiply this out to see what the product will be. Now the product of two matrices is defined as long as the number of columns in the first matrix is equal to the number of rows in the second matrix. So this is a 2 by 2, 2 rows by 2 columns, and this one is also a 2 by 2. Now because these two numbers are equal, we are allowed to multiply together. When you multiply two matrices together, you're going to multiply the corresponding entries in the first row of the first matrix times the entries in the first column of the second matrix, and then add those two products together. So let's set up the math for this product. We have 1 times 1 plus 0 times 2. So I got that by doing 1 times 1 plus 0 times 2. And for the rest of the entries, we'll follow in the same fashion. So the next entry is going to be 2 times 1 plus 1 times 2. Moving over to the second column, we're going to get 1 times 0 plus 0 times 1. And the very last entry is 2 times 0 plus 1 times 1. So we've set up the math for this product matrix, and now let's just simplify each of these entries. So 1 times 1 plus 0 times 2, this gives a 1. Then we have 2 times 1 plus 1 times 2. This equals 4. 1 times 0 plus 0 times 1, this gives us a 0. And 2 times 0 plus 1 times 1, this gives us a 1. So let's look at what the a value is, or the lower left-hand entry on a squared. Well, that's a 4. So let's start to keep a list here. If we have a1, we know that the a value in this was equal to 2. We saw that here. And we just solved for a squared, so the a value here was 4. Now let's see what a to the third power is. So we have a cubed. This is the same thing as a squared times a, because you're adding these exponents here to get a to the third power. So we know what a squared is. We solved for that here. So that's 1, 0, 4, 1. And we're multiplying that by matrix A, which was given in the problem. So 1, 0, 2, 1. And now we want to multiply these two together. So we're going to do the same setup as we did here for a squared. So we're going to multiply the corresponding entries in the first row of this matrix times the entries in the first column of the second matrix, and then add those two products together. So when we do this, we're going to get the matrix 1, 0, 6, 1. So now we found out that matrix A cubed gives us an a value of 6. That's this lower left-hand entry. And let's try one more. Let's try a to the fourth power. Well, this is the same thing as a to the third power times a. Again, we're adding these two exponents to give us a to the fourth power. Now we solved for a to the third power here. That's 1, 0, 6, 1 times matrix A, which is 1, 0, 2, 1. And again, we're going to multiply the corresponding entries in the first row of the first matrix times the entries in the first column of this second matrix and add those two products together. So when we do this, we get the matrix 1, 0, 8, 1. The lower left-hand entry is 8. So we have A 4. The A value in this case is 8. So let's look at our list here. Do we see any kind of pattern going on? Well, it seems like if we set up A to the power of n, how do we figure out what A will be? Well, let's see here. If we take this first power and multiply it by 2, so 1 times 2, we get 2, which is the A value. Let's see if it works for the second one. If we have 2 times 2, we get 4. So it looks like we have to multiply each exponent by 2 to get the A value. So 3 times 2 equals 6, which is this value here, and 4 times 2 equals 8, which is this value here. So if we have a to the power of n, the a value, the lowercase a value, is going to be n times 2, or 2n. So that's how we figure this out. So now we're asked to find this a entry for a to the power of 8. So following this setup here, we know that to get the a value, we have to do 2 times n, and then in this case, the n value is 8. So this equals 2 times 8, which equals 16. So we know that the a value in matrix A to the 8th power is going to be 16. So 16 is the final answer. Thanks for watching.